Hi, all. So, welcome back to the paging series and the memory management series of operating system. And this is the final section on the page replacement algorithm, which will conclude our memory management series of operating system. So, please bear with me. And this is a very interesting section that is the page replacement algorithm being used by the OS for demand paging. So let's begin with that. And there are certain algorithms that we are going to see in this lecture. So, okay, let's start with one of the most common algorithm, that is first in, first out. Okay, so this is first in, first out. So whatever that has entered first will go first, right? So let's say we have a reference string of pages. So we will be given some reference string. Let's say first page 7 is referred, then 0, then 1, then 2, then 0, then 3, then 0, and 4, then 2, then 3, then 0, then 3, then 2, then 1, then 2, then 0, then 1, and then 7, then 0, then 1. So all these are basically page number referred by CPU, page number referred by CPU, or by the process, we can say, from the LA. I mean, in the logical address, right? So this is the basic reference string. So first 7 is referred, page number 0 is referred, 1 2 0 3 0 4, then 2 3 0 3 2 1 2 0 1 and 7 0 1. So in this sequence, the pages are being asked in the logical address. So here, let's say we have a number of frames. Let's say number of frames in the physical memory or allocated to the process. We can say number of frames allocated to the process, let's say, is 4. Okay, now what is this number of frames? So we have seen that in the physical memory, we have divided the physical memory into certain number of pages, and for each pages we are allocating certain number of frames. So this is actually decided by the instruction set architecture. We can't decide, so this is somewhere hardware related, so it is decided by instruction set architecture of the process, right? So let's say we have the number of frames in the main memory as 4. So if we are using the page replacement algorithm as first in, first out, so we are required to find out how many page fault will occur when the reference string is like this and we have the number of frames in the main memory like 4. So for that, what we will do, we will create 4 frames. 1, 2, 3, and this one is 4, right? So we have created 4 frames like this. So all these are frame. So it is frame 1, frame 2, frame 3, and frame 4, right? And from here we will see that whether it is a page fault or not. So first of all, see the CPU generated the logical address requesting page number 7. So 7 is not present in any of these frames. So we are bringing 7 from the LAS into PAS into frame 1. So it is a page fault, right? Again, the CPU access 0. So again, we have 7 in page 7 in frame 1. So we will allocate 0 to frame 2, and this is also a page fault because 0 page is not present in the physical memory frame. Now it wants to access page number 1. So again, you see that 1 is also a page fault because it is also not present, and we will allocate page 1 in frame number 3. Okay, now again, we access 2. So 2 is also not present, so here we will allocate 2 here because one frame is empty, and 2 is also not present in the main memory, so it is also a page fault. Now the request came for 0. Now we will try to look into 0. So 0 is allocated to frame 2, so it is not a page fault, right? So we will make it as something like 0, 1, 2. It will remain the same. I mean, the structure remain the same, but here there is no page fault. Let's denote the page fault with F. I think P is let's denote with F. So F denotes the page fault. Okay. So altogether till now we have four page fault because all these pages were not present. So we just brought these pages from the LAS into the PS. So it is a page fault. But here it is not a page fault because 0 is already present in frame number 2. Now the request is for 3. So now we need to bring the 3 here. So we will apply the FCFS, first come first out, or FCFO, whatever. So here in this, whatever frame is bought first, we will replace it with the whatever page is brought first, we will replace it with the new page. So the very first page that is being brought is 7, right? 7 is the first page brought. So we will replace 7 with 0, bringing it from the main memory. So it is a page fault, and and we have applied page replacement algorithm here by replacing the first page with the new page being brought. Oh, sorry, it's 3, right? I'm really sorry. Just a second, let me erase this part. Okay, and yep. So it is 3. So 7 is replaced by 3, and then 0, then 1, then 2. Right now we have a request for again 0. Okay, so this is definitely not a page fault because second frame contains frame 0. Now let's say we have a request of 4, page number 4. It is not present. Now which page to replace? So after 7, which page came? Zeroth page came. So we will replace 0 with 4, and it is a page fault. So we will write it like this. Right. So basically now we need page number 2. So page number 2 is already present in frame number 4, so it is not a page fault. Okay, so it is not a page fault. Then we want to access 3. It is also definitely not a page fault, so it will be 3. Now we want to access 0. Now we already have replaced 0, so here we need to replace another page which is bought after 0, and that is 1. So first came 7, then 0, then 1. So we'll replace 1 with 0, 4, 3, 2, and this is also a page fault. Now came 3. So 3 is already present here in the list. I mean in the frame, so it is not a page fault. Then 2, 2 is already present. So it is also not a page fault. Then we have, we want 1. So 1 is not present. So we will replace the page which came after 1. Okay, so see, we are replacing the pages in the order they came. Okay, so first a page came 7, we replaced 7. Then came 0, we replaced 0. Then came 1, we replaced 1, and then came 2. Okay, now here also if you see, so what happens that 0 came after 7. So but we already have replaced 1 times 0. I mean, see, the order will be like 7, 0, 1, 2, and after 2 whatever came. So you have to see in this sequence. Okay, you have to see in this sequence which page came first, so you will be replacing that page accordingly. So 0 came after 2 here also. Before that 1 came, so here we will be we have replaced 1 here, right? After that 2 came. So now here out of 2, 0, 4, and 3, so out of all these, which page do we need to replace? So here after 2043, out of all these four pages, which pages came first? So from here we can see that 2 came first. Okay, so we will replace 2 with what number? We were on to 0, yeah, 1, 1043. So it is a page fault, right? So it is 1043. And now we are looking at 2. Okay, we replace 2 and now we are looking for 2. So for 1043 out of these 4, which page came first? So I think from here, if we look into uh, 0 came first, so we are replacing 0. Okay, and we will be replacing it with what? Mm, which one we are accessing? 2, right? Did I do some mistake here? Mm-hmm. Okay, just a second. 043 and no, just a second. We need to follow this order in which the pages came here. So after 0, out of this 2043, the frame came. We just replaced it with 0. So 0, we can't replace, right? So 0 came here. We have to see from this sequence. So out of 1043, so 3 came after 0, 3 came and then 1 came, but 4 came much earlier. So 4 came here. So we will be replacing 4. Okay, so we will be replacing 4 with 2 and 0, 1 and then 3. Okay, so we have to look at just from here. Okay, from the new frame. Now let's say if 0 came, so obviously we don't have here page fault. But after 1 came, obviously we don't have here page fault. Then after 7 came. Now for 7, this is the new frame and we have all the frames filled up. So we will look from 7 in this direction. Okay, so 1, 0, 2 are the just these pages came up, but 3 is came very earlier, so we will be replacing 3 with 7, and it is also a page fault. And then after that 0, 1 came, so there is no page fault for this. So all together we have how many page fault? So all together number of page fault, is equal to 10. So 10 page fault will be there. Let me illustrate it with 3 frames. Let's say we have all together 3 frames in the memory. So let's say this is 3 frames. Okay, let's assume the sequence here. So the sequence is 7, 0, 1, 2, 0, 3. Then we have 0, 4, 2, 3, 0, 3. Okay, and 3, 0, 3, and then 2, 1, 2, and then 0, 1, 7, and then 0, 1. So it's the same sequence, I believe. Let's see what are the page faults. So first we are accessing 7, so it is a page fault. Let's do it fast. So 7, after that we are accessing 0, so it is also a page fault because it is not present in this frame. Then we are having 0, 7, 0, 1, so it is also a page fault. Then we want 2 and it is already filled up. So which page we are going to replace? So for 2, for this pointer we will see just previously. So 1 just came, 0 just came, but 7 came much earlier. So in among all these 3, 7 is the first one that came. I mean 7 is the very first one to come into this frame, so we will be replacing 7 with 2, and then it is a page fault. Then 0, we don't actually need 0. I mean 0 is already present, so it is not a page fault. Sorry. Then we just move to 3. Now for 3, just look at this sequence. So in this sequence, 2 just came, 0 just came, 2 just came, 0 just came, but 1 came much earlier. So 1 is the one to be replaced by 3, and then 0, 2, so it is also a page fault. Then again we are accessing 0, so it is not a page fault. Now we are accessing 4. So we will, for 4 we will be looking at this series. So 0302. So 0 we are not going to replace, is just came. Then 3 also just came, so we are replacing 2 with 4, because 2 is the first one to come into the series of request. Now we want 2. So for 2 we will be looking at this series. So 4 we can't replace, just came. 0 we can't replace, 3 we can replace. So 3 we are replacing it with 2, 0, 4. And this is also a page fault. Then we have 3. So out of 240, 0 is the one which will be replaced by 3. And then 4, 2, so it is also a page fault. Then we want 0. So out of 4 to 3 we are replacing 4 with 0, because 4 is the first to come. And then it is also a page fault. Then we have we want to access 3. So it is already present, we don't need to replace. Then we have 2. So we don't need to replace this either. Then we have 1. So out of 0, 3, 2, 0 is the one which is getting replaced, because it is the first to come. So 1, 0 is replaced by 1. And then 3, 2, it is also a page fault. Then came 2. So we don't need to replace anything, it is already present. Then we have 0. So in 2, 1, 3, 2, 1, 3, 3 is the one will be replaced by 0. So this is also a page fault. Then we want to access 1. So we don't need to replace anything, so it is no page fault. Then we have 7. So out of 102, 2 is the one we need to replace with 7. So it is a page fault. Okay. After that we have 0 and 1, which is the next. So we 0 we don't need to replace, and also 1 we don't need to replace. So altogether if we count here, how many page fault is there? So so altogether it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So altogether we have total number of 12 page fault, right? So yep. So this way we can calculate the number of page faults, right? With the help of 1, 2, 3 frames. I think it is fine, right? 2, 3, 4, 5, 6. Yeah, it's 12 only, right? Okay, so this way we can calculate the page fault part. So we'll see some of all other algorithms next in the upcoming video. So till that, please do keep watching. And if you do have any comment or question, please do comment in the comment section. Thank you very much.